In this video, we're going to look at a linear search or a sequential search. The linear search approach compares a key element sequentially with each element in an array. The method continues to do so until the key matches the element in the list, or if we get all the way through the list without ever finding a match, we're going to return a -1. If we do find a match, we're going to return the element in that array. We're going to return its index number so we know where that element was found in the array. So let's take a little view of it. Say we're looking for the number 3 and we have this array full of integers. Basically, we're going to look at item 0 in the integer. Is 6 match 3? Nope. Let's look at the next one. Does 4 match 3? Nope. Let's look at the next one. Does 1 match 3? And we're going to keep going through all the items in the list, comparing item 0, then item 1, item 2, item 3, item 4. Finally, at item 5 matches the item we're searching for, so we are going to return the value 5. If we would get all the way through the list, all the way through the array, I still don't like that this book uses the word list. If we get all the way through the array and search all the values and we never find it, we need to return a -1. So let's look at some code that actually does this. Right here, I've set up an array of integers called int array, and I have the values 1, 4, 4, 2, 5, -3, 6, and 2. Okay, and then I am printing out 3 different calls to this sequential search method that I've created. And when I call it, I'm passing in a reference to this array. And I'm also passing it the number that I'm looking for. Okay, so the first time I'm going to pass this array and the number 4. The second time I'm going to pass this array and the number -4. And the third time I'm passing this array and the number -3. So let's see how this works. We call sequential search. We pass in a reference to the array and a copy of the number 4. They get stored in these variables called search array, which is an array of ints. Okay, and the item we're going to look for is an int called search item. And we have a small for loop that's going to count up, as we've seen many times, from 0, as long as I stays less than the length of the array itself. And each time through, we're going to look to see if the item we're searching for, which was search item, is equal to search array sub I. So search array sub 0, search array sub 1, search array sub 2. If those two things are equal, we're immediately going to return the index number where we're at. And that will end this method and return us back to the point in which it was called, in which the results then will get printed using this print line statement in this case. If we go all through this list and this condition is never met, this return statement will never happen. That means we never found the number that we were looking for, and we return a -1. So the -1 that gets returned is an indication to whoever called the method that the item was not found. So they could say something like, if the result equals -1, print the item was not found. Otherwise, we could, if the result's not -1, we could print the item was found in index number 5. Okay, so each of these will print it out with a 4. It should find it at index 0, 1 will be the spot where it finds it. It won't find it here because it's going to go through in order. Okay, then it's going to go through with the -4, and there is no -4 in here, so this one should return a -1, which will get printed out to the screen. And then we're going to search for a -3, and that's at 0, 1, 2, 3, 4, 5 is where it finds -3. So if we run this, I see a 1 for the 4. We found a 4 at index 1. -4 was never found, so the function returned, the method returned a -1. -3 was found at index 5. Okay. So that's a sequential search, using a for loop to go through a list, an array, one element at a time till we find the thing we're looking for. It works great for small arrays. It does not work so great when you get up to elements. What if we had 1 million elements? How long would it take to search through 1 million elements that way? So there are more efficient ways to search than a sequential search, and we'll discuss that in an upcoming video.